Hey guys, we're going to start with 4.5, isosceles and equilateral triangles. And the first one we're going to talk about is an isosceles triangle. The important thing to know about an isosceles triangle is that it will have two congruent sides, called the legs, and two congruent base angles right at the bottom of those two congruent legs. So here's what our isosceles triangle looks like. All right. We have a triangle that I've drawn, and I've gone ahead and marked each of these legs congruent. Right where those two legs meet is the vertex. And then right at the bottom of those two legs are your base angles. And what I highlighted here in green is the base. Okay, so right at the bottom of the two congruent legs are base angles. And then we're going to move down to an isosceles triangle theorem. Another theorem for you. It states, if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So, let's look at this triangle. We're going to say that, hold on, getting a little crazy here. If AC, this segment, is congruent to BC, this segment, then these base angles, angles A and B, they will be congruent to each other as well. That's the isosceles triangle theorem. Okay, and moving along to the converse of the isosceles triangle theorem. Converse, remember, this is when we flip things around. So it states, if two angles of a triangle are congruent, two angles this time, then the sides opposite those angles are congruent as well. So we're going to look at this portion right here. If angle A is congruent to angle B, right? Hold on, I'm going down too far. These two angles are congruent. Then because of the converse of the isosceles triangle theorem, we can now state that AC is congruent to BC. So, basically, if we know that two sides are congruent of a triangle, then their base angles are going to be congruent. If we know that two base angles are congruent, then we know that their two sides are going to be congruent as well. Now let's talk about Theorem 4.5. If a line bisects the vertex of an isosceles triangle, so a line bisects it, there's that word again, remember, cuts it perfectly in half. If a line bisects the vertex of an isosceles triangle, then the line is also the perpendicular bisector of the base. So here we have a triangle. We know it's isosceles because each of these legs are marked congruent. And here's a line that comes down and it bisects it, meaning that because it bisects it, both of these angles are going to be congruent to each other. So if AC is congruent to BC, and angle ACD, this angle, is congruent to this angle, BCD, then we can say that CD, this line coming down, is perpendicular to AB, and AD, oops, I'm missing a little D here, is congruent to BD. So these pieces are congruent to each other. So when we have Theorem 4.5, we have this perpendicular bisector. We end up having two congruent angles. We have a perpendicular line here, so we have a 90-degree angle. And not only that, we have two other congruent pieces, AD and DB. Okay, well, some of you don't have this worksheet yet, because Mrs. Black was kind of a space case and forgot to hand it out to all of the classes. So what we're going to talk about here is we're going to talk about scaling. Scaling means that no sides are congruent. You can have three different types of scaling triangles. Let me zoom out a little bit so you can get a better image here. All right, you can have an acute scaling triangle, meaning that all the angles are less than 90 degrees. Now let's see if we can't get it to focus better. I guess that's a little bit better. You can have a right triangle A right scalene triangle where you'll have one right angle and then two little acute angles. And then you can have an obtuse triangle where you'll have one obtuse angle and two acute angles. Equiangular, all three congruent angles, that's not going to happen in a scalene since none of the sides are congruent. None of the angles can be either. All right. And then isosceles, right here at the top. You have at least two, that's a 2 there, it's kind of hard to see, at least two congruent sides. Okay, so isosceles, we can have an isosceles acute. Again, all angles are less than 90, so angle A and angle A. Remember the base angles of an isosceles are congruent, and right at the top will be angle B. You can have a right isosceles triangle, right? We've seen this before, 45, 45, 90. Again, congruent base angles, and then a 90-degree angle at the top. It's right. And then an obtuse one, right? You have two base angles that are congruent, and then up here is angle A, our one acute angle. And then down here, equiangular. Well, you can't have an equiangular isosceles triangle because these legs would be congruent, right? And these base angles are congruent. So equiangular, it would be isosceles as well. And we move over here to equilateral. Let me just move my paper. Where all three sides are congruent. Well, you can have an acute equiangular. Every side will be 60, 60, 60, 60. You will have 180. And there you go. You cannot have a right equiangular triangle. No right equiangular. That won't happen because if one angle is 90, well, they all three can't be 90, right? For equilateral, because that would be more than 180 degrees, which is more than a triangle is. Nor can you have an equilateral right triangle because, equilateral obtuse triangle, because those all have to be over 90, right? So again, that would be greater than 180. We can't have that. And you can't have an equilateral, and you can have an equilateral equiangular because if all the angles are the same, then all the sides will be the same as well. And what I did up here in the corner is I just went ahead and identified acute as purple, right as turquoise, and pink as obtuse. It's hard to tell in these diagrams, but these purple down here on this triangle, the obtuse isosceles would represent acute and acute, and then the pink A would represent obtuse. Anyway, that's it for 4.5, and I'll see you guys later.